So, if you unplug the local monitor from a retail store's central server, every massive digital billboard in that building should, like, instantly go black.
Hmm.
But today, we are looking at the invisible digital infrastructure that prevents that exact disaster. Welcome to your custom-tailored deep dive.
Yeah, thanks. Our mission today is to explore how modern retail displays actually function. And we're using a highly specific source for this, the technical product page for the Smart-AVI DVS-400S 4-port DVI-D CAT6 STP Extender.
Okay, let's unpack this because understanding this single, metal box unlocks the mechanics of massive multi-screen video networks.
Right, exactly.
And the primary physical problem here is distance. Sending high-quality, uncompressed video hundreds of feet is essentially like trying to whisper a complex secret across a crowded football field.
That is a great analogy. By the time the sound reaches the end zone, the signal is either, entirely degraded or completely drowned out by noise.
Right, it's just totally lost.
Yeah, and standard DVI-D cables max out around 15 feet before losing bandwidth.
Wait, really? Only 15 feet.
Yeah, just 15 feet. So the DVS-400S gets around that bottleneck by converting the digital video signal to run over CT6 STP cabling.
Okay, so STP, that stands for shielded twisted pair, right?
Exactly, shielded twisted pair. By leveraging the cable's internal wire twisting and, like, the outer shielding, it actively cancels out electromagnetic interference.
Wow.
And that mechanism is what pushes a flawless 1920 by 1200 resolution at 60 hertz, a full 220 feet out to remote displays.
That is a huge jump from 15 feet.
It really is. What's fascinating here is how the source material grounds this in a highly practical scenario.
Right.
Like, a retail shop can seamlessly broadcast high-res media files from one hidden back-office computer out to 4 screens across the store, plus one local screen for the staff.
But pushing a signal 220 feet creates a massive new vulnerability.
Oh, definitely.
Because you've now got this delicate hardware chain stretched across an entire building. If someone in that busy back office accidentally kicks the main local monitor's plug out of the wall...
Which happens literally all the time.
Right. The graphics card loses that physical hardware handshake and immediately drops the video output.
Yeah, the GPU halts the video feed because, well, without that handshake, it just assumes there's nowhere to send the image.
So an entire store's digital signage just goes dark over a bumped cord.
Exactly.
Well, here's where it gets really interesting, because the DVS-400S doesn't just pass a video signal along. It actually acts as a phantom monitor.
Right, yeah, it features automatic DDC.
Display data channel learning, yeah.
Exactly, display data channel learning. It essentially stores the local monitor's profile, the EDI, in its onboard flash memory. So it's effectively ghosting the connection.
Oh, wow.
It's exactly like having a designated proxy in a corporate meeting. Even if the boss, the physical monitor, steps out of the room.
The proxy holds their exact voting credentials so the meeting doesn't get canceled.
You got it. The source computer reads that stored profile and remains completely unaware that the physical hardware was unplugged.
That is so clever.
The device retains the memory and just keeps outputting the video to those remote screens without a single flicker. If we connect this to the bigger picture, the sheer utility is striking.
Oh, for sure.
I mean, a business secures total uninterrupted system stability for a $399 unit that just slots right into a standard 19-inch rack.
Right. It structurally isolates the network from basic human error in the back room.
Yeah.
So what does this all mean?
That is the big question.
Well, it means the next time you are relaxing in a high-end lounge looking at perfectly synchronized screens, you'll know exactly what kind of hidden SAKI 6 web is powering them.
Yeah, and you'll know about the phantom monitors ghosting the connections to keep it all stable.
Exactly.
Which, this raises an important question for you to consider.
Okay, let's hear it.
If a simple video splitter now needs to create a permanent memory of physical hardware just to prevent a system failure from a bumped cord, how soon until even our most basic cables require built-in artificial intelligence to anticipate and actively hide our physical mistakes?
Wow, yeah. It fundamentally changes how we view infrastructure. I mean, we used to build digital bridges just to carry a signal from point A to point B.
Right, but going forward, the hardware itself might have to constantly impersonate the devices we break just to keep our networks alive.